What's up guys, this is Masi. Welcome to my channel. This video I want to talk about diprotic acid. In previous videos I talked about acids and bases, and I defined strong acids, weak acids, and acid dissociation constant. Now I talk about diprotic acids. Diprotic acids are those acids that they have more than one or actually two protons. Diprotic acid is an acid having two acidic protons. So they have two protons that they can lose. The sulfuric acid is actually a diprotic acid, an acid having two acidic protons. So if we see this reaction, sulfuric acid is H2SO4. When it dissolves in water, water is not shown here. When it dissolves in water, it dissociated completely 100% into its ions, into its conjugate acid and conjugate base, because sulfuric acid is a strong acid. So H2SO4 is going to be one-way reaction. It's going to be irreversible reaction. It results in proton and HSO4 minus. HSO4 minus is the conjugate base for sulfuric acid. And then HSO4 minus, it still has one more proton that it can lose. So we call it acidic proton. Remember, not all hydrogens are acidic protons. So those hydrogen that chemicals can lose to become conjugate base are called acidic proton. So in the second reaction, we have a weak acid. HSO4 minus is a weak acid. It loses one proton, the second proton, and it results in proton and SO4 2 minus, which is the sulfate ion. So we have two reactions. The first one is strong acid and the second one is the weak acid. So whenever we have a diprotic acid, or sometimes called polyprotic acids, it means that we have more than one acidic proton. Usually, if the first reaction is strong acid, the other reactions, the second or third reactions, are definitely a weak acid and weak reaction. So although the first reaction is one way or irreversible, the second one or even the third one is gonna be a reversible reaction, because we have the second one and third one are weak acids. Sometimes even the first reaction is also a weak acid. For example, when we are talking about phosphoric acid is H3PO4. It has three protons, three acidic protons. Even the first reaction is weak acid. The first, because H3PO4 is also a weak acid. So as you go down, the Ka, which is the acid dissociation constant, is reducing as well. So when we are talking about phosphoric acid, we have Ka1, Ka2, and Ka3. So Ka1 is greater than Ka2, and Ka2 is greater than Ka3. So these are the definition for diprotic acids and polyprotic acids. I hope you enjoyed this video. Please like this video if you find it useful, and you can subscribe this channel to find lots of videos regarding math and science. Thank you for watching. Have a great day.